Okay, good morning everyone. So today now we move to the module 4, software engineering. This actually is a module which will answer an important question. So as you can see, the module 4, as I've written here, is about deployment, maintenance, software quality, etc. Yeah. So I said this will answer an important question, which is after we write the software, the code, what happens next? So does the life cycle end? No, right? Not at all. So as we all know and we've discussed earlier, software has to be deployed, then maintained, improved, then monitored. And this is actually a continuous evolution. So we understand that it is continuously evolving. And that is exactly what this module explores. So let's start with deployment in this. We'll move to slide 1. Okay. So this actually basically tells you what a deployment is, as you can see in the slide. So imagine that you develop a great application, but it stays only on your laptop. So can the user access it? No, right? So basically, deployment is the process of making software available in the real world, right? So it must be on the servers or on the cloud or basically at least on production environment. So it actually acts as the bridge between development and usage. So what did you understand? Without deployment, software has no value delivery, which is why after the definition of what is deployment, the deployment is a process of making a software application available for use in a production environment. It's written, and in the next part, you can also see that I've written a poor deployment or any poor deployment practices can lead to system downtime, data loss, etc. You can read that. Okay. Now, what makes deployment successful? Okay, so you can see this is the first line which says successful deployment follows three fundamental principles that ensures software transition smoothly from the development to the production environment, which we already touch based, right? Okay. The first thing is reliability. So every deployment should follow a consistent process, right? It has to be consistent, it has to be repeatable, and the same steps has to be followed, errors has to be minimized, and then we should be able to predict what the outcomes are. Basically, the users must be able to place a trust. Whenever I need this, this is available. That is reliability. Like, okay, I can trust on this and it will work as intended without any errors. Okay, so that was the first point. The second point is minimal downtime. So users basically don't like feeling interrupted, right? So basically they shouldn't have or shouldn't feel interruptions. See, think about an online bank. Okay, so the moment you try any transaction, if it actually crashes or there's a downtime, it definitely creates panic, right? Why, especially when you are trying to transfer some money, it has gone from your bank, you're not sure. By the time you get a confirmation, the system had a downtime, etc. Right? So it has to be like a little constantly available so that the users don't panic. So basically when we have deployments or rolling updates which allow especially new versions to go live while maintaining service continuity for users, then that would be the best. Okay. Now the third one is a rollback support. Okay. So if something goes wrong, rollback, right? Rolling back to what was there earlier. If something goes wrong, we would or we should revert to the previous stable version. That's the term, okay? Stable version. So every deployment must include a very quick rollback mechanism. Now moving to the methods, okay, manual versus automated deployment method. Okay. So basically, any organization can actually choose between a manual and automated approach. Okay, so each of these methods will have their own specific characteristics, which will affect the speed, the reliability, the resources used, the requirements of the resources used, etc. So basically, manual deployment means humans will execute each and every step. So it gives actually good control. But the problem is that it will increase the risk of errors. Whereas automated deployment will use many tools, scripts, etc. So it may be a little faster, obviously, than the manual one. It will be consistent, it will be scalable as well. So basically, in industry, automation will dominate because of, right, anything we get fast, quick, and which is reliable, that obviously gets the priority. Okay, so you have to go through these points, like what makes a difference when we use a manual one, when we use an automated one. It is there in the slide. Anyway, I'll be sending you the notes so you can relate to what I said. So a quick run through would be like a direct human control, is there in the manual. And manual basically we can use for very small projects, and which will not have continuous releases. The releases will be very infrequent. Then I told you already, there is a risk of human error. And then automated is always fast, but manual is always time consuming, etc. So please go through all these. Now, yeah, introduction to continuous integration and continuous deployment. That is what CI/CD means. Okay, so that represents a modern approach to our software development, which will actually focus on things like automation, then frequent integration, and then quick and rapid delivery. Okay, so these are actually practices which has become the industry standard for an efficient software development. Okay, so we'll now try to understand what a continuous integration, CI, and a continuous deployment, CDS. Okay, so have you faced integration problems while merging code in group projects? So if yes, this is where CI/CD will help. So it emphasizes frequent integration, automation, and rapid delivery. So what is continuous integration? So that is the way where we practice, quite frequently merging code changes into somewhere which is shared into a shared repository, and many times in a day. Okay, so each integration will trigger automated builds of our code and also tests of our code to detect the errors quickly. Okay, so this ensures, the continuous integration ensures that code from, that is very important point. Okay, code from multiple developers will work together correctly and also uh, detect or catch errors very early in the stage of development. Okay, so now continuous deployment will actually, this is an extension of the CI. Okay, that will automatically deploy all the code changes which different developers work on, and it will pass automated test results to all the production environments which is associated. So every successful build or the test is now automatically given to users without manual intervention. Okay, so basically the continuous deployment ensures that the software which we develop, and every improvement in the software which we develop will reach the users very quickly and reliably. Okay. Now, how does continuous continuous uh, deployment will help us? Okay, so now continuous integration, we know, right, means developers frequently merge their code into the shared repository, and each merge trigger automate builds, also automated tests. So errors will be detected early, reducing the debugging needs much later. And similarly, we said continuous deployment will actually, that's a an evolvement. Okay, so that will go one step further than the CI. So if our the code build passes the test, it will automatically be deployed to the production, right? So what is the advantage of that? This will ensure faster delivery and frequent updates to the user. Okay. Now, yeah, as we said, what are the benefits? Okay, so benefits are listed here: faster time to market, early bug detection, reduced integration risk, improved developer productivity, etc. So basically, from the developer point of view, it will free the developer from repetitive tasks because it is automated, right? Okay, now build and automation fundamentals. Okay, so build automation basically is the process of uh, converting the source code automatically into executable software, right? So you have an idea of the steps, right? So automatic conversion has to include the compilation, like the compiling the code, then running the tests, then packaging applications, and basically preparing them for the deployment. So build automation basically covers or converting source code into executable software in one line. Okay, so it ensures consistency. Now we actually have two common build tools here. So you can see two names there, right? Maven and Gradle. Okay. So these are build tools. What is the difference? Maven will use XML configuration. We all know XML, right? Yeah, and it is widely used in projects which uses Java. So it will manage project dependencies, it will compile source code, it will run the tests, it will package the applications, etc. So Gradle, when compared to Maven, is more flexible, it is more faster with the script-based configuration. Now moving to software maintenance. We all do, we've used this term many times from module 1, right? From the software development life cycle. So in this we understand that we've just done with the deployment. So deployment is not the end. Software has to survive the changes. Okay. So what is software maintenance? So software maintenance consists of all the steps which is needed to keep a software system operational after the deployment, right? So what may be the steps involved? It will involve any further modifications of the code, updations and enhancements to correct the faults, and then improving the performance and also adapting to all the changing environment, right? It includes all modifications after deployment basically. So maintenance will consume 60 to 80% of the life cycle cost. This you should remember. Okay. Now we have to see the types of software maintenance. There are four types. One is the corrective maintenance, another is the adaptive maintenance, the third is the perfective maintenance, and the last one is the preventive maintenance. So basically, one look into it, corrective means obviously we are correcting. So what do we correct? The bugs, right? So this is basically fixing the bugs. Okay. Adaptive, again, very easy from the literal meaning, right? So this is getting adapted to new environments. So updating for new environments. Right? Perfective. When does something become perfect? While we keep improving it, right? Yeah, so perfective maintenance is for improving the feature. And the last one is preventive. So what is preventive, as we all know? So I am trying to prevent anything that can happen in the future. I predict, I prevent. So avoiding future issues. Now, so basically, what is re-engineering? Okay, so software re-engineering will always there is a re means doing it again for some obvious reason, right? So re-engineering will restructure the existing software. Why? To improve quality and maintainability. Very easy. Okay. So basically, we are restructuring, we're not rebuilding, right? The existing thing we are restructuring so that we can improve the quality. So this definitely is cost effective compared to rebuilding. Okay. Now another term is reverse engineering. Okay. So what is reverse engineering? It is a process which analyzes existing systems to understand design and functionality. So when do you have to use this? It is useful when documentation is missing. Okay, so this is a very important point, right? So reverse engineering will actually progress through various stages. Like you'll have to first see the executable code because documentation is missing, and then through the executable code you have to analyze the system behavior. Then you may have to reconstruct the design modules, test it, and document the further findings. So it is basically useful when the documentation is missing and will help understand the legacy systems. Okay. Then we move to the term called refactoring. So what is refactoring? It will actually improve the code structure, but how? Without changing external behavior. Okay. So this is basically a very disciplined technique. So we'll have an existing code and we are going to restructure the code without changing its external behavior. So it can be, anything, even a small improvement to the code structure, a small improvement